particle starts from rest and travels in a straight line with acceleration cos pi t meters per second squared. We want to find the displacement of the particle after 2 seconds. Well, we're going to assume that the start point is where displacement is measured from in the absence of any further information. In other words, x is 0 when t is 0. So we know that A is cos pi t. So to get velocity, we integrate A with respect to t. So that's going to be the integral of cos pi t dt. Now, if we refer to our trigonometric cycle, cos integrates to sine. The argument doesn't change, so it's going to be pi t, but this is a case where the inside function differentiates to a constant, so we're going to use reverse chain. We need to divide that by pi and add the constant. Now we know that v is equal to 0 when t is equal to 0. Sine of 0 is 0, so that means that the c is equal to 0 as well. So v is just going to be sine pi t all over pi. So x we know is the integral of v dt. So x is going to be the integral of sine pi t over pi dt. Remember, pi is just a constant. Sine integrates to negative cos. So this is going to be negative cos pi t. Using the reverse chain, we need another pi on the bottom. So x is equal to 0 when t equals 0. That's what we assumed, that the start point is where we're measuring from. And so what does that mean? So 0 equals, well, cos of 0 is 1. So negative 1 over pi squared plus c. So therefore c must be 1 over pi squared. So x is going to be negative cos pi t over pi squared plus 1 over pi squared. Now what we're asked for is x of 2. So that's going to be negative cos 2 pi over pi squared plus 1 over pi squared. Cos of 2 pi, same as cos of 0, is 1, so that's negative 1 over pi squared plus 1 over pi squared, which is 0. So at 2 seconds, it's back at the start point. We now want the distance travelled by the particle in the first 2 seconds. We know the displacement was 0. We just got that from part A. So if this is a start point, what must have happened is it's travelled away and come back. So what we want to find is whereabouts it stopped and started coming back again. So that's going to happen when v equals 0. So v equals 0 means sine pi t over pi is equal to 0, which means that sine pi t is equal to 0. Now let's think about the sine. So at 0 it's 0, and at pi, and then at 2 pi. So this is going to be when it first stops here. So that means that t is equal to 1, not 0, 1. Sine pi is 0. We know that's true. And t is 1 is between t is 0 and t equals 2, so that makes sense. So it's going to turn around at that point there. So let's work out x of 1. So let's find out where it is, where it stops. So x of 1 is going to be negative cos pi over pi squared plus 1 over pi squared. Now, cos pi is negative 1, so this is going to end up being 1 over pi squared plus 1 over pi squared, so that's 2 over pi squared. So in other words, it's travelled 2 over pi squared out here, and then to get back it's got to travel 2 over pi squared back. So the distance travelled is going to be 2 over pi squared, not equals, plus 2 over pi squared, which is 4 over pi squared meters.